Well, there's been some activity underground near Joburg, an earthquake measuring 3.3 on the Richter scale recorded this morning between Carttonneville and Western area. It seems mining activity in that area may have set off the tremors. Simon Gear is a man who understands how to make the earth move. Simon, good afternoon to you. When we have tremors like this, what's going on underground?
Yeah, good afternoon, Stephen. Look, that area, when I read the reports and saw it was between Carttonneville and Western area, I knew straight away it had to be mining related. That entire area is honeycombed with old gold mines and some very, very active ones still. And I think what essentially happens is that the release of pressure, you know, as old pilings give way, and you might have a small collapse in an uninhabited part of the mine or an unused part of one of those old gold mines, and that's enough to just set off a bit of an earthquake.
It was relatively small, but people would have actually felt it. I mean, do we need to worry? Are tremors linked to other tremors? If you have one, could that set off a chain reaction in some way?
You could, certainly with big tectonic earthquakes, so those are the ones that places like Tokyo and San Francisco worry about, where you've got two plates on the surface rubbing up against each other. Those do often come in series. With these ones, it's a very, very localized event. So, you know, we in Joburg have an incredibly stable part of the crust that we live on. And so while maybe you might have one or two, you know, there's now obviously some instability in that area and maybe further collapses might happen, but it's certainly not anything to worry about.
You talk about places where there are massive earthquakes. I mean, often people talk about the ring of fire, where you have so many earthquakes that you have an earthquake underground, it can set off a tsunami, all sorts of things can happen. Where's the technology on actually predicting what's happening underground? How difficult is that to do?
Incredibly difficult to do, Stephen. What happens is that pressure builds up along those fault lines over many, many years, and then it's suddenly released. And you hear stories of maybe animals able to predict it or something like that, but that's never ever been able to be proven by science, and certainly scientists themselves are really not able to predict earthquakes at all. We're able to predict volcanoes. You know, we can see when a volcano is beginning to rumble and beginning to get ominous, but earthquakes, no, I'm afraid they tend to come by surprise.
Well, we have you. I mean, I do want to ask you a little bit about weather as well, because we've had a huge amount of rain over the last few weeks. We've all felt the impact of that. If you're in Ladysmith at the moment, you've probably got your TV on a box just to keep it out of the water. What causes this? Now, my understanding is that it's linked to La Nina. A quick Google search tells me that what's happening with our rainfall is actually linked to the temperature of the Pacific. How does that work?
Yeah, so the El Nino-La Nina system, El Nino is the one that we tend to sort of know, and then La Nina is the opposite, is when there's a shift in temperature in the Pacific. And it was first named in Spanish, El Nino is a little boy, because it happened around about Christmas time, and the subsequent drought devastated the Peruvian fishing industry. But you get a knock-on effect right across the oceans. And so we also get heating and warming in the Indian Ocean. And that accounts for about 30% of the variability in our rainfall. So it's not a sort of direct link that we've got a La Nina system and then a single big thunderstorm happens. It's more that when we are in a La Nina cycle, so we're in the wet phase of that cycle, so then we can expect a slightly enhanced rainfall, or a slightly better chance of summer rainfall across central and eastern South Africa, in fact, all the way up into East Africa as well.
So, I mean, it's really true, then, that something that happens in the Pacific, as far away from southern Africa as you can get, actually has an impact on what we're having now.
Yes, so it's, you know, the changes in temperatures there change the wind patterns above the ocean there, and that has a knock-on effect all the way across the ocean. And we have to remember that the climate pattern is actually a fairly small system. It does all affect each other. You know, things like the cold fronts we get are probably mostly caused by waves in those westerly winds caused by air flowing over the Chilean mountains. So everything is very, very much connected.
So does what happens in the Atlantic, or what happens in the Indian Ocean, oceans that we know much better, I mean, does that affect the weather in China?
It does. I mean, certainly El Nino La Nina is the big one and tends to have its source, in fact, just north of New Zealand, and we can sort of track it back across. I suppose the best example of this is climate change. You know, carbon dioxide that's pushed into the atmosphere in China absolutely lands up affecting our overall climate as well.
And then what changes the temperature in the Pacific that leads to all of this? I mean, is that also connected to another system of some kind?
Yeah, so it's all a very complex system that is very, very circular. But essentially, it's a weakening of the flow of wind across that area. That weakens the upwelling, so you don't get very, very cold water coming up off the coast of Peru, and that in turn heats the atmosphere above that, changing the wind patterns, and the whole thing, knocks back across the Pacific and the Indian Oceans and lands up affecting our weather, not just our weather around the world. And different places are affected different ways. We just happen in South Africa to associate El Nino with drought and La Nina with wetter weather.
Simon Gere, thanks very much indeed. I think there's almost anything I could ask you, you'd have an answer for. I really do appreciate it. Simon Gere, technically, I suppose, a climatologist. Thanks very much.